Illustrative Math, Algebra 2, Unit 6, Lesson 9 is called Introduction to Trigonometric Functions. So our goal today is I can use the coordinates of points on the unit circle to graph a sine and cosine function. All right, so suppose P is on the unit circle at 1, 0. Describe how the x-coordinate of P changes as it rotates once counterclockwise. So it's going to go all the way around the circle like that. And then describe how the y-coordinate changes. Okay, so go ahead, pause the video and see if you can describe the x and y coordinates. Okay, so I'm going to say here the x coordinate starts at 1 and decreases until it gets to -1, and then it starts increasing again until it ends where it started at 1. Okay, so we're talking the x coordinates, a unit circle. So this is 1 unit for the radius. So this is 1, 0. And it just, I can click on it, whoops. And as I move here, it's still positive until I get to pi over 2. Then it starts getting negative, and then it reaches its minimum there at -1, and then it starts increasing again, still negative until it gets to 3 pi over 2, and then it keeps increasing and it reaches its max at 1. Okay, and now the y-coordinate. The y-coordinate starts at 0 and increases until it gets to 1, and then it starts decreasing until it gets to -1, and then increases again to 0. Okay, so you can kind of think of it like, okay, it starts at 0 here, it's going to increase to 1, and then it starts decreasing until it gets to -1 right here, and then it increases back to 0. Okay, you can also think of these points here as, 0, 1, -1, 0, 0, -1, and we said this was 1, 0. Okay, so there you go. All right, use technology to plot both the values of y equals cosine theta, where theta is the measure of an angle in radians. So I'm going to change this from x to theta. So it says use technology to graph. I'm going to try it without technology. So I'm going to say here, this is 0. This is pi over 2. This is pi. This would be 3 pi over 2's. And then when we get back to 0, it's almost the same as saying 2 pi, because pi is half and then another pi, so 2 pi. So the unit circle, remember the radius is 1 unit. So if I'm going to do cosine first, okay, we're looking at the x coordinate. So just like I did on the last slide, I'm going to put all these coordinates here. All right, so I start at 1. So let's do this. I'm going to put 1 right there. So I go by halves. Start at 1, and then at pi over 2, the x-coordinate is 0. At pi, the x-coordinate is -1. 3 pi over 2, the x-coordinate is back to 0. And then at 2 pi, the x-coordinate is back to 1. Okay, so your graph is going to look something like this. Now, it's actually kind of curved. You might be tempted to make it like kind of zigzag, but it's actually kind of smooth and curved like that. Okay, and then this one here would be the y-coordinates. So I'll put the 1 here and the -1 here. The y-coordinate would be these values. So I'll underline those in green so we know which is which. So at 0, we start at 0. At pi over 2, we're up to 1. At pi, we're back to 0. At 3 pi over 2, we're down here at negative 1. And then 2 pi, we're back to 0. So your graph would look something like that. And this was y equals sine of theta. And this one was y equals cosine of theta. So they're very similar graphs. The difference is, like, notice that the sine graph starts at the origin, whereas the cosine graph starts at 1. And, they're kind of just like a horizontal translation of each other. Okay. So what do you notice about the two graphs? I would say for number 3, I would say similar. Cosine starts at 1 on y-axis. Sine starts at origin. Okay. And let's see, explain why any angle measured between 0 and 2 pi gives a point on each graph. Okay, so any angle between 0 and 2 pi. So, like you might have, let's say we got right here, this is pi over 4. It'd be like kind of like you divide your pi into 1, 2, 3, 4 sectors. So, the sine of pi over 4 is going to be, or the point on the unit circle is radical 2 over 2, radical 2 over 2. Okay, how did I get that? Well, pi over 4 is 45 degrees. So if I made a triangle here, I would know that this would have to be isosceles. The rate hypotenuse is 1. You could use geometry here to figure that out. You could say x squared plus y squared, and they're both the same because it's isosceles. So anyways, but that's not necessarily too important for what we're doing. But I want you to realize here, so, any angle, it's going to always have a point there, okay? So, as I move my angle along here, there's always an x coordinate, okay, on this circle. It's continuous, okay? So I would say something here like along the lines of, as you move around the unit circle, it is continuous, and there will always be an x coordinate for each angle. Okay, that was for number 4. Move that here so you can read that a little bit better. And then 5, could you use these graphs to represent functions? Explain your reasoning. So a function, each input has to have one output. So I would say, yes, each input will give us exactly one output. So they could represent functions. Okay, so meaning instead of using y, I could say f of theta, or g of theta. So, if I wanted to call this, f of theta equals cosine theta. Now I can write it as a function. I call this g of theta equals sine of theta. All right, just like that. Okay, let's take a look at the actual technology, graphs with technology here. Okay, this is my, well, that's my sine one. Whoops, I have them backwards. So this one here is this graph. This is y equals cosine theta, and then this one here is y equals sine of theta. Okay, so you can see nice and smooth, not zigzag. And that's what ends up happening there. Okay. All right, so looking at the graphs of y equals cosine theta and sine of theta, at what values of theta do cosine of theta equal sine of theta? Oh, you know what? Let's go right here. I put this on another slide, so it's a little bit easier. Okay, so where do they equal each other? So where they equal would be where they intersect. So here and here. So my answer would be, oops, so my answer would be at pi over 4 and 5 pi over 4. Okay. Remember, pi over 4 means you cut, let me go back here, you cut your semicircle here, this half circle. It's like you cut it into fours. So be like that and like that. So 1, 2, 3, 4, and then 5 pi over 4s would have to come down here. So this point right here would be 5 pi over 4. 1, 2, 3, 4. There's 5 pi over 4. All right. Pi over 4 is obviously that first point in quadrant 1. All right, so now we're going to take this, the blue one here. Let's go back and remember what we talked about. The blue one, since it starts at the origin, this is y equals sine of theta. And the red one is y equals cosine of theta. So we're going to add them together. So you're basically adding the y coordinates. So I'll do it here in green. So at 0, it's 0 plus 1 is 1. I'll put these points here. Pi over 2, this is like, I don't know, we'll say 0.8 plus 0.8, so it's going to be like 1.6. So pi over 4 is halfway between pi over 2, so I'm going to put it like right about there in the middle here. Pi over 2, this is 0 plus 1, so that's at 1. 3 pi over 4, this is going to be, call it 0.8 plus negative 0.8, so that's going to be down here at 0. Pi is going to be like 0 plus negative 1, so that's down here at negative 1. 5 pi over 4 is like negative 0.8 plus negative 0.8, so I'm going to say negative 1.6. 3 pi over 2 is 0 plus negative 1, so that's at negative 1. This is going to be like 0.8 plus negative 0.8, so that's at 0. And notice I put it right there. This is 7 pi over 4. It's like halfway between 3 pi over 2 and pi over 2. And then 2 pi is 1 plus 0 would be at 1. So it looks like my graph looks like this. And I have to make it dotted because I'm just not good at tracing with my pen that I use. And let's take a look at the graph with technology. Looks pretty good. Okay. All right. Y equals cosine squared. So what I'm going to do here is I'm going to take my cosine graph and I'm going to square all the coordinates. So 1 squared would still be 1. This would be, I'm going to maybe streamline a little bit. I'm going to go to pi over 2. 0 squared is 0. Pi negative 1 squared would be 1. I'm going to go to 3 pi over 2. 0 squared is 0. And 2 pi 1 squared is 1. So it looks like this graph is going to look something like that. Okay. And sure enough, it starts at 1, goes down to 0. And I'm just basically plugging in the numbers from the red graph here and squaring them. Now, one thing to say here, this is a little weird with the cosine squared here. This means cosine of theta squared. So it's really cosine of theta times cosine of theta. And that's the way it's written with the exponent right there. Okay. All right, next one. Oh, you know what I need? I need to, I'm going to bring this graph with me. All right, so I'll put it here to help me. So sine squared. All right, so the sine is the blue one because it starts at the origin. I'll write it right here just so we got it. Sine of theta, and then this was y equals cosine theta. All right, so I'm going to, again, streamline. I'm just going to do the pi over 2's. So 0 squared is 0. Pi over 2, 1 squared is 1. Pi squared, 0 squared, 0. 3 pi, negative 1 squared is 1. And then 0 squared, 0. So this one will look something like that, okay? And let's take a look at that graph. Looks pretty good. All right, and then the last one here, I gotta move this somewhere. I'll put it right here, I guess. All right, so cosine squared plus sine squared. Okay, whoa, a lot of math I gotta do here. So 1 squared plus 0 squared is 1. I go to pi over 2. 1 squared plus 0 squared is 1. 0 squared plus negative 1 squared. 0 squared, 0. Negative 1 squared is 1. Remember, negative 1 squared is negative 1 times negative 1, okay? A lot of people accidentally think it's negative 1, but that's 1. 0 squared plus negative 1 squared at 3 pi over 2 is 1. And then same thing here. So it looks like it's it's like a straight line. Now, could I plug in pi over 4? I could. Now, this is, again, I don't know the exact value there, so it might be kind of be inaccurate, but let me move this graph here, and let's see if we were right. Oh, yeah, it is a straight line. Cool, so that's kind of neat. That's good to know. This is actually what's called a Pythagorean identity, so you're going to want to maybe like put that in your memory bank, but that's called a Pythagorean identity. All right, we won't use this yet, but we will use it very soon. All right, so lesson synthesis, graph y equals sine of theta. Here it is. Obviously, we start at the origin. It reaches the max at pi over 2, back to 0 at pi, reaches a minimum at 3 pi over 2 at negative 1, and then back here at 2 pi. What is the value of the second tick mark on the theta axis? So halfway between 0 and pi over 2, if you wanted to take pi over 2 times 1/2, because you're halfway, you're going to get pi over 4 right here. That's sloppy. Pi over 4. There we go. What's the first? Oh, shoot. I answered that wrong. This is pi over 4. Sorry. The second tick mark was pi over 2. The last tick mark is 2 pi. And when does it cross why does it cross the x-axis at the fourth tick mark? Well, I would say the sine of 2 pi equals 0. And if you think about your unit circle, okay, if you got your unit circle here, okay, when you get back, a little off, whoops. When you get back here at 2 pi, this has a sine of 0. So the y-coordinate is 0, okay? All right. A student who missed class today isn't sure if this is a graph of y equals cosine theta or y equals sine theta. Explain how I would use the features of the graph to convince them which it is. Well, I would say look at these points here. And I would say the x-coordinate on the unit circle at 0 degrees. I'm going to go back. I'm going to copy this thing here. I would say, oops. I don't know why it's doing that. All right, well, forget that. Let me go back here. Let me draw a new one. So I got my unit circle right here. So I would just say here at 0 degrees, the cosine is 1, which at 0 degrees, the cosine is 1. Okay, so it's looking like the cosine because it starts up there. Sorry, I just got moved. I was trying to... At pi over 2, cosine is 0, which is right there. At pi over here, this is pi over 2. At pi, it is at -1, which it is. So definitely, I would say this is y equals cosine of theta, especially because it starts at the top. Sine starts at the origin. All right, hope you enjoyed this video. Thanks for watching, and we'll see you next time.